Section 3.3, this is very much a continuation of what we covered in 3.2. All right, so to check if x minus k is a factor of p of x, p of x being a polynomial, divide p of x by x minus k. If the remainder is 0, it's a factor, otherwise it's not. So is x plus 1 a factor? Okay, so we're going to do synthetic division. So the opposite of positive 1 is negative 1, so I put negative 1 in my box. Then my coefficients. So I've got 2, and then I don't have an x squared, so I got to put a 0 for that. Then I've got a 1x and a 2. Skip a space, draw a line, bring down the 2. Alright, then we have negative 2, negative 2, 2, 3, negative 3, negative 1. So, negative 1 is not equal to 0, therefore the answer to their question is no. Not a factor, because when you divide it, it has a remainder that is not 0. So, alrighty, let's see. So our goal is eventually going to be to factor polynomials this way. Alright, factor f of x given that k is a 0 of f of x. Alright, so they're telling me that 2 is a 0 of that polynomial. So I'm going to put 2 in the box. And then my coefficients, I have 2, negative 3, negative 5, 6. Skip a space, draw a line, bring down the 2, 4, 1, 2, negative 3, negative 6, 0. Alright, and that is as we expected. Oops. Sorry. That is as we expected, a remainder of 0, since they told us that that is a 0 of the function. So again, that was bring down the 2, and then 2 times 2 is 4, negative 3 plus 4 is 1, 1 times 2 is 2, negative 5 plus 2 is negative 3, negative 3 times 2 is negative 6, and then 6 minus 6 is 0. So now we know that f of x, which is this function right here, we have figured out a first step of factoring it is going to be x minus the k, which is 2, and then here this is going to be 2x squared plus 1x minus 3. So 2x squared plus x minus 3. Okay, so we have factored it a little bit there, and then our goal is to factor it, so they want us to factor this part right here. Okay, so we could factor that by using either guess and check or the AC method. So I'm going to bring down the x minus 2. So I think guess and check would be pretty easy on this one because there's not a whole lot of options. We've got 2x squared, so I know that I need a 2x and an x to multiply together to equal 2x squared. That's pretty much the only way to make that work. Alright. So let's see. And I know I'm going to have like, it's either going to be 1 and 3, 3 and 1 to make 3. The fact that it's negative does make it a little bit more complicated, because I know one of them will be positive, one will be negative. Just have to figure out which one it is. So I kind of use, I guess, a combination of the guess and check and the AC method when to me is the easiest way to do this. I don't want 3 to get multiplied by 2 because that's going to make a 6, and I'm not going to be able to get this 1 here. So I need my 3 to go here and my 1 to go here. That way, when I FOIL it, I would have, this would make a 2 and this would make a 3, and the difference between those gives me the 1 here. So let's see, now in order to make it a positive 1, I need my bigger number to be positive, which is going to be the 3. And then that's going to make, so that's going to make positive 3, that's going to make negative 2, and then that's going to make 1x there. Alright, so that's basically it for that problem. It is now completely factored, which was the goal. Okay, there we go. So that's the factored form of that polynomial. Okie doke. Let's see. Number 3. Alright, so same exact thing here. Same instructions. So let me put negative 5 in the box. And then my coefficients, I've got 8, 50, 47, negative 15. Skip a space. Draw a line, bring down the 8. Alright, so that'll be negative 40, 10, negative 50, negative 3, positive 15, and 0. Again, we know that this had to come out to be 0, so good there. Alright, so let's start the factoring process. So now we know that f of x is equal to x, so it would be like minus negative 5, so basically it would be plus 5. And then you're going to have 8x squared plus 10x minus 3. Okay. Alrighty then, let's see. So we got to factor that. So let's basically just use the AC method, I guess. So A's 8, C's negative 3. So A times C, 8 times negative 3 is negative 24. So we have to figure out two numbers that multiply to negative 24 and add up to 10. So what about 2 and 12? Negative 2 and positive 12. That would do it, right? Okay. So now I'm going to rewrite this, and instead of 10x, I'm going to write minus 2x plus 12x. Alright, so that's just replacing the 10x there. And then I'm just going to bring everything else straight down. Okay, and I'm just going to go ahead and bring everything. Alright. Now let's see. Alright, so now I'm going to factor it by grouping. I'm going to factor this part by grouping here. So I can factor out, the greatest common factor for that would be 2x. So 8x squared divided by 2x would be 4x. And then 2x divided by 2x would be 1. Okay. Oh, whoops, that's supposed to be plus. Okay, what's the GCF between 12x and 3? That would be 4. No, I'm sorry, that would be 3. So 12x divided by 3 is 4x, and 3 divided by 3 is 1. So there we go. Then we have 4x minus 1, so we bring that out. That's kind of like a new GCF. And then I've got 2x plus 3, like so. And again, I'll bring down x plus 5. Alright, so that is the factored form of the polynomial function. So here's the expanded form of the function. Here is the factored form of the function. Alrighty, let's see. Next page. Alright, so it says, given that 1/2 is a 0 of f of x, find all the other zeros. Okie dokie, so 1/2 is going to go in the box. And my coefficients, I've got 4, 6, -2, -1. Bring down the 4, 2, 8, 4, 2, 1, 0. Again, we knew that 0 would come out there. Okay, so our goal here is to find all the other zeros, but I'll go ahead and start with, actually, no, I don't really need to factor it, I don't guess, because what I need to do is just fill this in, so it'll be 4x squared plus 8x plus 2, and basically set it equal to 0 and solve that. That's what I need to do to find my other zeros, is to solve this. Okay, so the first thing I notice is that all of my coefficients are divisible by 2. So why not go ahead and just divide everything by 2 and make it a little easier. So that make it 2x squared plus 4x plus 1 equals 0. So if this is factorable, it would be very easy to factor. There's not very many possibilities. You'd have to have basically 2x times x to give you the 2x squared. And everything's positive, so these would have to be positive, and the only numbers that can multiply to 1 is 1 and 1. So if it's factorable, it would have to be this. But is that right? Well, let's just kind of check with FOIL. So we already know that these two terms would be right. The real question is, would this term be right? So 2x plus 1x would equal 3x, not 4x. So no, that's not right, which means it's not factorable. So then our only choice is to use the quadratic formula. Okay, so x equals -4 plus or minus the square root of 4 squared minus 4 times 2 times 1 all over 2 times 2. Okay. So that would be 16 minus 8, which is 8. 2 times 2 is 4. All right. We can break down the square root of 8 with a factor tree. So the square root of 8 turns into 2 times the square root of 2. Okay. All right, so let's see. So we're just simplifying it at this point. We can't cancel these 4's out because you've got two terms here that both have to get divided by 4. So you can either split that into 2 fractions, or you can just reduce by 2, like basically, so that's 2, and that's 2, and that turns into a 1. So your final answer would be -2 plus or minus the square root of 2 all over 2. All right, and then remember, plus or minus is just a shortcut way of saying two separate answers, one that has a plus and one that has a minus. So if you're typing this in on the computer, you might have to separate your two answers with a comma. So it would be like that, comma, yeah, so it could be like that. Okay, so that's your other 2 zeros. Alrighty. Okay, getting to some good stuff here. possible rational zeros theorem. All right, so let's say we have a polynomial. All right, so the first term, first of all, you've got these terms in order of descending powers. So this is your term with your highest power, which is your leading term. And then this is your constant term here that doesn't have any variable. All right, so in that case, you can come up with a finite list of possible rational zeros. Okay, so rational, so if you have a number with a, like, that has a square root in it that can't be simplified any further, that is irrational. Okay, so that's not rational. So these would be non-rational. 1/2 is rational, okay, because it's an integer over an integer. This can't be written as just an integer over an integer. Okay. All right, so this is used to come up with a finite list of possible rational zeros. Okay, so it's plus or minus any factor of C over any factor of A. All right, so let's come up with the list of possible rational zeros for number 5. So we've got a leading coefficient of an invisible 1 here. We got a constant term of -8. It's going to be, the answer here is going to be plus or minus anyway, regardless of whether this is positive or negative. It doesn't matter. All right, so I'm going to start. All right, so on the numerator, you're going to have possible factors of 8. So factors of 8 would be 1, 2, 4, and 8. So basically it's any whole numbers that can go into 8. And then on the denominator, you're going to have factors of, in this case, 1, which would just be 1. All right, so when your leading coefficient is 1, that always makes it real easy because it's just, you don't even have to really worry about it. So your final answer, I'm going to write it as plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. Okay, so those are the possible rational zeros. Okay, so that's essentially, plus or minus is 2 different ones. So 2, 4, 6, 8, that's basically 8 possible rational zeros. Okay, so the zeros of the polynomial, which are also, if they are, well, the rational zeros will come from this list. Okay, all right. So no other rational number can be a 0 of this polynomial. Okay, let's do the same thing for number 6. That one's a little bit more complicated because our leading coefficient is not 1. All right, so on the numerator, we're going to have the factors of 12. So that would be 1, 2, 3, 4, 6, and 12. And then on the denominator, we're going to have factors of 3, which is 1 and 3. Okay, so okay, how many factors of 12 are there? 1, 2, 3, 4, 5, 6. 6 factors of 12, 2 factors of 3. Okay, so 6 times 2 is 12. So if I basically have all the possible combinations of one of these over one of these, there's going to be 12 possible combinations. So I'm going to just write 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. All right. And then, okay, so I'm going to kind of do this systematically in some way. The order doesn't really matter, but just put it in some kind of order, kind of helps you keep track. So I'm going to go 1, 2, 3, 4, 6, 12, 1, 2, 3, 4, 6, 12, and then I can go 1, 1, 1, 1, 1, 1, 3, 3, 3, 3, 3, 3. Okay, so now what I'm going to do, so all of these are going to reduce. Obviously, they're over 1. So I'm going to start writing down my final answer. So and I'm going to put plus or minus with each one for my final answer. Oops, sorry. Okay, so, you know, like I said, the 1 is just, you know, reduces out. Plus or minus 6. Plus or minus 12. Okay, now let's look. Now, okay, then next we are going to have plus or minus 1/3. Plus or minus 2/3. Now, 3/3 is 1, which we already have written down, so we don't need to write that one down again. Next, we'll have plus or minus 4/3. 6/3 is 2, which we already have written down, so we don't need to write that down again. And 12/3 is 4, which we already have written down, so we don't need to write that down again either. Alright, so here is my list of possible rational zeros. So that's the answer for that one. Okay, let's see here. Okay. I said it says here that you're supposed to find the actual rational zeros and factor it, but I'm not sure if we're ready for that yet. I obviously didn't leave myself enough room here, so thinking that's going to come maybe a little bit later. In the next section, we'll definitely do that. Okay, let's move on to, maybe I want to break up my video here. Yeah. Let's go ahead and cut this video here, and then there'll be a part B. Alright? Alright, so we're ending here. Okay, part B will start here.